Hello all, thanks for hopping on. We're just going to give it a couple minutes before we get started today. Thanks for joining all. We're going to get into a quick video from our sponsor, Drone Deploy, before we get started. And hello, everyone. Welcome to the CxEnergy Virtual 2021 webinar series. If you're coming back, welcome again. And if this is a new webinar for you, thank you for coming and stopping by. And special thanks to Drone Deploy for sponsoring this specific presentation. Some of you may know the drill by now, but I'm still going to address a few important notes before we get started on our webinar today. In order to receive a certificate of completion, you must be registered attendee and use the personalized link that was sent to your email address to join the webinar, not a link that may have been shared with you. Once each live presentation concludes, you will receive an email with your certificate within 24 hours. Additionally, if you are a CXA, EMP, or TBE, staff will be uploading your certificates of attendance for you. And this will be completed after the final presentation after this week. All live webinars are being recorded, so if you happen to miss one, you will have a chance to view it after. During the session, we encourage you to submit questions at any time using that Q&A button you see on your screen. The chat function is where you can make general comments and chat with attendees. And if you happen to be experiencing any technical issues during the webinar, please use that same chat function to inform the panelists and we will assist you. Today's webinar is Remote Energy Management during COVID-19, utilizing benchmarking tools to target cost-saving opportunities. And a few words on our speakers today. Carolyn is a program manager at the Berkeley National Laboratory. Prior to joining Berkeley Lab, she worked in management consulting for 15 years, assisting companies to improve sustainability performance through operational excellence. She is the lead researcher for the award-winning Building Efficiency Targeting Tool for Energy Retrofits, also known as BETTER, which we will be discussing today. She's joined by Eric, who is the principal and founder of Energy Resources Integration, or ERI. He directs ERI specialists in remote data analytics, field assessments, energy modeling, and and emerging technology assessments. For utility clients across the US, he leads ERI's demand-side management program implementation. And he's joined by Ethan, who is an engineering manager at ERI. He leads energy audits, recommissioning, and technical reviews of commercial buildings, data centers, industrial customers, wastewater treatment plants, pump stations, and oil and gas sectors for energy efficiency and self-generation projects. So without further ado, I'm going to hand it off to Carolyn to get us started today. Carolyn?
Thank you so much, Sam. My first question for anyone that's on the line. Great, my slides are showing correctly. So I'm delighted to be here today with my colleagues from Energy Resources Integration to discuss and introduce innovative energy management techniques during COVID-19, utilizing benchmarking tools to target cost-saving opportunities. The global buildings market presents us with unique challenges, but also opportunities. Building operations account for about 28% of total global carbon dioxide emissions. When combined with embodied CO2 emissions from materials and construction, the sector accounts for 39% of global CO2 emissions. According to Architecture 2030, less than 1% of buildings are retrofitted annually to improve energy performance and decarbonize. In order for us to stabilize atmospheric concentrations of CO2 over the next several decades, we're going to need a substantial increase in the speed and scale of building energy efficiency retrofits. Key barriers preventing implementation of retrofits are that preparing building for retrofits can be both time-consuming and costly, particularly when we're looking at large portfolios of buildings, 10, 20, 10, hundreds, thousands, tens of thousands of buildings, at a cost of 10 cents per square foot for just a basic level 1 ASHRAE audit. We're looking at, could be tens of thousands, hundreds of thousands, millions of dollars. Researchers at Lawrence Berkeley National Lab partnered with Johnson Controls to introduce an innovative web application, the Building Efficiency Targeting Tool for Energy Retrofits. This is a free, open source, public access, lightweight web application offered with funding, supported with funding from the U.S. Department of Energy Building Technologies Office. This tool provides the global buildings marketplace with an easy-to-use web application to target efficiency improvements by turning readily available monthly utility bill information into specific measurable energy efficiency interventions, both operational and technological, at both the building and portfolio levels. It's important to recognize that Better doesn't replace an ASHRAE Level 2 investment grade audit, but it does provide a preliminary estimate in the size and the makeup of potential energy efficiency projects. So more along the lines of a Level 1 basic audit. Better is highly scalable, meaning it can be used to target efficiency opportunities in one or many buildings. It's not a rating tool. It doesn't provide a path or score to certification. And very critically, it complements and interacts with DOE's existing network of tools, the Energy Star Portfolio Manager tool, Asset Score, Building Sync, and the Standard Energy Efficiency Data Platform. Better recently won a couple of prestigious awards for advancing the science of data-driven remote building energy analysis to improve efficiency at speed and scale. You can see on the left there, an Oscar of Innovation and R&D 100 award, recognizing Better as one of the most disruptive and innovative technologies of 2020. Also a Director's Award from Lawrence Berkeley National Lab for tech transfer. We set forth some ambitious R&D goals when developing and introducing Better into the market. We wanted to keep the data requirements minimal, and Better uses less than half of the data inputs of competitor tools. Also a very short runtime. We use a unique parallel inverse modeling process, allowing Better to analyze a single building in just seconds and a large portfolio in just minutes. The scalable application that I mentioned earlier. So we can quantify the savings potential and recommend energy efficiency measures for a single building, an entire portfolio in a single analytical run, And ERI is going to talk more about their use of Better across their large portfolio in the state of California. Better can compare a building's energy performance against either a built-in reference data set or the user's own building portfolio. We also include a flexible savings target, allowing users with several different options to improve building and portfolio energy performance. They can target deeper energy and cost and emissions reductions, or if they're just getting started, set targets for more conservative savings, allowing them to gradually increase the level of energy efficiency they achieve in buildings and across their portfolio. Better fully automates regression analysis and benchmarking. We understand from professionals that have used Better that it saves them significant time and money due to this fully automated inverse modeling process and benchmarking capability. A typical preparation of an inverse model for a building might take an engineer maybe an hour to prepare. With Better, just seconds. Next, open source analytical engine. As a U.S. Department of Energy National Laboratory, we are using, we're offering the analytical engine open source on the GitHub platform. Also, opportunities for investors to utilize Better to target energy efficiency investments, and of course, promoting energy justice. So using
Hi,
simply
Carolyn.
simple.
Sorry to interrupt. I believe that your slides aren't advancing. It's still on the awards slide.
Thank you. So I'm going to talk a little bit about the introduction. I'm going to talk a little bit about the workflow for Better. We're taking simple building data inputs combined with weather data from the National Oceanic Atmospheric Administration weather database, and monthly utility bill information provided by a user. Better will pre-process this information, create inverse models for each and every building in a portfolio. You can see the inverse model in the center portion of the graph. From this model, Better will identify model coefficients, isolate them, and benchmark them against a peer group. The benchmarking of the coefficients is combined with a user's entry for a retrofit target level. We combine that with Johnson Controls lean energy analysis to identify energy efficiency measures and quantify the size and the makeup of potential projects. We then generate reports both at a portfolio and building level, providing users with valuable information on where to target energy efficiency upgrades in buildings. Data inputs. I want to talk a little bit about Better's data inputs. As I mentioned earlier, we're focused on using as few data inputs as possible in order to target energy and energy efficiency retrofit opportunities in buildings and portfolios. We require use of a building identification number, name, location, gross floor area, primary building space type, and currency. This allows us to quantify cost savings potential in terms that will resonate with the user. With regard to utility bill inputs, it's a minimum of 12 consecutive months of energy usage and energy usage data for all fuels used in the building, including for each fuel. So we're looking at monthly billing start and end date, the energy type, unit, monthly energy usage, and cost. We'll pull average outdoor air temperature from the from the National Oceanic Atmospheric Administration database, about 80 to 100 weather stations globally as far back as 2010. Better works in the following way. We automatically pre-process the address, space type, and gross floor area data input by a user and the monthly energy usage and cost data. Better will search for the closest weather station, combine different types of fossil fuel consumption, and convert energy consumption units into kW, which on the back end. When we report, we'll report in the actual fuels and units input by a user. At the same time, Better is going to be downloading sub-hourly weather data from NOAA. It will align and aggregate the weather data with energy consumption data provided by a user. So we're essentially plotting average daily outdoor air temperature against average daily energy use intensity on a monthly basis for the past 12 months. Better normalizes this energy and creates the following types of models, which are shown here. You can see the schematic plots and the model coefficients. Better can generate up to 5 model types, a 1-parameter model, a 3-parameter cooling model, the 3-parameter heating model, and the 5-parameter model. If you're familiar with the ASHRAE Inverse Modeling Toolkit, you'll understand that these plots and the coefficients within the models themselves can be interpreted to understand the performance of different systems and equipment in a building. So I'm going to take the example of the 3-parameter cooling model, which is the second model from the top. In this model, Better is plotting along the x-axis average daily outdoor air temperature for the last 12 months, and along the y-axis average daily energy use intensity for the last 12 months, creating a plot fitting a model, and then identifying following 3 model coefficients: the base load, the cooling sensitive consumption, and the cooling change point. The horizontal portion, i.e. the base load, provides us with an indication of the level of performance of various base load systems in a building, such as the combination of light, plug loads, and process loads. The slope portion of the model, that coefficient is a function of the building envelope, ventilation, infiltration air, and the efficiency of the heating or cooling system. In this case, because we're looking at outdoor air temperatures rising, as we move further to the right of the graph, this is an indication of the level of efficiency of a cooling system. That point in the middle, C1, would be a break-even temperature point and is a function of the temperature set points in the building. Essentially, what Better is doing is creating these models, identifying these coefficients, isolating them, and benchmarking them against peers. Here's an example of how this works. So let's take the example of electric base load. We're looking at one building in particular on the upper left of this slide. Better will create the inverse model, identify the level of performance for base load electricity, and in the analytical engine at the same time is creating a combination of benchmark statistics. First, from an underlying data set, either provided by the user or developed by Lawrence Berkeley National Lab, it's determining the median and standard deviation for that electric base load level for the larger building database. Better will take the single building and determine where it falls relative to the median and standard deviation. If the electric base load is better than 1 standard deviation from the median, Better will determine that to be good performance. Worse than 1 standard deviation from the median, Better will determine that to be poor performance, and anything in between would be typical. In this example, we see electric base load is actually is several standard deviations better than the median, and therefore good performance. Better will perform this analysis for all model coefficients: base load, cooling sensitive consumption, cooling change point, heating sensitive consumption, and heating change point. With this information, Better will quantify, again, total potential energy cost and emission reduction on a per building basis and at a portfolio level, as well as identify the specific measures necessary to implement at either a building or portfolio level to capture that savings. Here's a look at what a typical single building analytical report looks like. We'll see the cost savings, the energy savings, and the greenhouse gas emission reduction. We can also look at the breakdown of electricity cost savings potential versus fossil fuel cost saving potential. Here we see energy efficiency recommendations for a specific building, information on how the building is currently spending utility bills. Is most of the building's energy costs attributable to base load? Is it attributable to cooling? Is it attributable to heating, etc.? I'll look at this further when we do a live demo. I think it will be clear for attendees. Also, the cost savings breakdown. In this case, the building's cost savings potential is split fairly evenly between improvements in base load as well as improvements in heating sensitive consumption in the building. We can also look at energy consumption trends over the past 12 months. The yellow line indicates current consumption levels as pertains to either electricity or fossil fuel, with the green indicating potential improved consumption levels if the energy efficiency recommendations for a particular building are implemented. Here we have the change point models for each building, and again, the benchmark analysis. I'll look at this a little further when we go to the live demo. Better not only recommends technology improvements or improvements to equipment and systems in a building, but we've built into the tool a number of no and low-cost operational interventions which can be used immediately to cut energy use, emissions, and costs across the portfolio. We roll these no-cost and low-cost operational interventions into the following categories: reducing equipment schedules, lighting load, reducing plug load, optimizing heating and cooling set points, optimizing ventilation, decreasing infiltration, increasing heating and cooling system efficiency, and adding in and fixing economizers. Okay, moving on to the live demo. So as I mentioned before, Better is a free public access web application sponsored by the U.S. Department of Energy. The tool is up and running live, and we encourage folks at the end of today's training to please check it out. The web app itself includes some basic information on how the tool works. Some of the information I discussed a moment ago regarding inverse modeling, identification and benchmarking of coefficients, and the generation of energy efficiency recommendations and quantification of energy and cost saving potential. We have a helpful YouTube video that describes how to use Better, a number of publications and pre-recorded trainings regarding data collection, as well as implementing many of the no and low cost energy efficiency measures recommended by Better. We have our application programming interface link here. If you have questions or want to use our API, please contact us at the link shown below. We include our source code on GitHub. And for those that are on the developer side of things, it's open source, and we just ask that any enhancements or contributions made to the source code are shared with the Lawrence Berkeley National Lab development team. Some of our latest news and information about the tool is shown here, and frequently asked questions. So without further ado, I'm going to go ahead and walk you through a run of Better. User would simply click Run Better, and they'd be taken to this data entry page. At this point in time, we have a couple methods for uploading data. You could either use an Excel-based data entry template. You can download it from the link here, and then enter the data required for use of Better, and then simply click on the data entry template radio dial button Better, click Browse, upload it from your computer, and then select the building type that you'd like to analyze. I've pre-uploaded some data due to the time constraints today, and this happens to be an office portfolio for the city of Washington, D.C. Washington has public access information about its building stock, so we simply downloaded this from the public database in Washington, D.C. I'm going to analyze all buildings in this portfolio. To do that, you simply click this dial button here, or alternatively, you can select on an individual basis which buildings you'd like to analyze in a particular run. Once a user has done that, they'll click the next button below and come to the following page, which allows a user to set savings targets, either conservative, nominal, or aggressive. As mentioned earlier, Better allows for some flexibility as to how aggressive you want your energy savings across a portfolio or within buildings to be. Conservative targets, nominal targets mean that for each of the model coefficients identified in an underlying database, we're going to set the target level as the median level for that particular coefficient. In cases where a building operator or portfolio operator may be looking for more aggressive energy and cost savings, they'll want to select aggressive savings where the benchmark coefficients for which will quantify savings and cost potential and recommend energy efficiency measures will be a half a standard deviation better than the data set median. Conservative, a full standard deviation worse than the median. I'm going to go with a nominal savings target here, and then a user would also need to select whether they would like to benchmark a particular building against LBNL's default data sets. These are data sets that we've created as researchers derive from building data from the US national stock, or generate their own coefficients. And what that means is essentially benchmarking one building in your portfolio to the standard, to the median and standard deviation levels for coefficients for the remainder of the buildings in a portfolio. In this case, I'm going to go with the default benchmark statistics level, the minimum R squared level. Again, that just tells us to what extent are the models accurately and precisely predicting energy cost emissions reductions and targeting the right energy efficiency measures for a building or portfolio. The higher the R squared model, the higher the levels of accuracy and precision in the models. A user then would click run and then receive a link that says generate portfolio output report. Click on that link and you'll arrive at the first of several reports generated by Better. Here we see a portfolio summary report for the 26 office buildings for Washington, D.C. that I just entered. Better predicts the cost savings level of about $2.5 million per year. That's a 21% cost savings potential, and an energy savings level of about 18%. The breakdown between electricity and fossil is also shown, and the total greenhouse gas emission reduction potential. More portfolio energy and cost details are shown in these drop-downs. Along with this, Better will identify the top 5 energy efficiency recommendations to be applied across the portfolio. You click on each of these links, you'll see the measure itself along with the individual buildings for which that measure applies. Also, an energy consumption and savings summary allows for some use here, some interactivity to identify quickly the buildings that represent the highest cost savings potential. Buildings that are using fossil can also be quickly identified to determine which buildings may need support for electrification in order to achieve net zero energy or net zero energy ready targets. Again, some quick analysis offered by the tool, even prior to setting foot in a building. This sortable chart allows a user to rank and sort buildings based on energy cost and emissions reduction potential. Click on a link and you'll go to a single building report, which will provide all of the detailed information I just mentioned, but at a building level. You'll see the energy efficiency recommendations, current utility bill, cost breakdown, how your building is spending on an annual basis with regard to heating, what a typical building spends, and what your goal could be. And you can do that for base load, cooling, individually or combined. The cost savings breakdown, again, here most of the cost savings come from the base load and the energy consumption trend information that I explained earlier. Also the change point models, so you can see the original data and how Better fit the model, and then how those model coefficients benchmark against peers. Lastly, some energy efficiency recommendations. We include basic high-level information to guide energy portfolio users and how to identify and implement these efficiency measures. Lots of great resources from the US DOE and the National Labs. So with that, I will turn it over to my colleagues at ERI to talk about their application of the Better tool.
Great, thank you, Carolyn. So wait for the slides to come up here. There we go. Great, thank you. So as Carolyn mentioned, I'm going to talk about how we're using Better with a particular California state agency to help them work toward the state of California's energy reduction goals. So a little bit about ERI. Energy Resources Integration is an energy engineering consulting company. We're headquartered in San Francisco and focused on energy efficiency. So our team provides energy analytics, modeling, energy audits, retro commissioning, and sustainability planning services. We support the implementation of utility administered energy efficiency programs, as well as working directly with end users to help identify ways to reduce consumption and increase efficiency. So in our work with this state agency, their particular efforts were driven largely by Executive Order B-1812 in California, which was enacted by Governor Brown in 2012. And it's driven a lot of California's efforts over the past 8 or 9 years. So And this executive order encompassed a wide range of goals and actions. One of the key components focused on energy efficiency. For example, commissioning in particular was identified, and some of the language from the order stated that new and existing buildings incorporate building commissioning to facilitate improved and efficient building operation. So I'm going to talk a little bit about our work with this state agency, which involved, some education that was provided to them, benchmarking and prioritization, and then how we performed energy audits and retro commissioning to target particular sites. And I'll talk a little bit about our approach both before and after using the Better tool. Next slide, please. So ERI has worked with this state agency for nearly a decade now. And the relationship started with education on the loading order. So making sure that they pursue cost-effective energy efficiency first and reduce their consumption as much as possible prior to pursuing other things such as self-generation or other strategies in their facilities. We discussed with them common energy efficiency measures that they might consider for these facilities, and then the programs from the utilities that can help them reach their goals, and incentives to make it financially viable. So this led to performing some energy usage intensity analyses for their over 450 facilities throughout the state to identify really which buildings were the largest consumers and least efficient. So this was used basically a basic EUI analysis, and so that buildings with their largest and highest EUI buildings, we targeted about 9 buildings for energy audits. And from those, we found that retro commissioning was appropriate for about 5 of them to do a more detailed retro commissioning analysis. The other ones, it was mainly cost prohibitive due to an antiquated control system. So the best options in those cases were to focus on a revamp or overhaul of the controls to enable strategies that could be used in the future. So for those 5 that were selected for retro commissioning, we then did a detailed study, modeled their usage, and developed some measures that they could pursue. Most of them came out to about less than a 1-year payback. So it's very, very cost effective, which was what they were aiming for this first round of retrofit work on these buildings. So that was before the Better tool. And next slide, please. And then more recently, over the past couple of years, we've used the Better tool through a pilot project to study their portfolio of buildings. And it's really helped to enable us to target those buildings much more efficiently and effectively. It's essentially sped up that targeting process by about 50% by not having to conduct on-site assessments to gauge which buildings are best for retro commissioning, but rather we can use a Better tool to quickly identify the best buildings that are suited for RCX. And the Better tool gives us that recommended measures, and we can easily see which buildings are a good fit to study for retro commissioning, and then we can directly target those rather than first going on site to do that preliminary scoping audit. So so it really improved that process, allowed us to identify measures quickly and easily, reducing the time and money spent during the course of the scoping process to identify measures. And so we targeted targeted these audits, went on site, and we actually confirmed after going on site for some of these that these sites that were targeted and identified, we confirmed and validated the savings and measures that were projected using the Better tool. So a couple of examples of buildings. There was Modesto building, which was about an 80-year-old building, and then Madera building, which was constructed within the last 5 years. And both of these actually presented great opportunities for retro commissioning. For example, with Modesto, we were able to identify about 500,000 kilowatt hours in savings. And so, so a really effective way to go about it. We've found that, you know, the results from these buildings that we've looked at in detail really back up what we saw in these initial stages using the Better tool. So, it's just made the entire process very effective in being able to move quickly forward with this agency's efforts and minimize the time spent in those preliminary stages of targeting. So I'm going to hand it off to Ethan now, and he's going to describe a little more about how we've used the tool specifically.
Thank you, Eric. So working with the state agency has been a interesting process to learn how to do large building assessments to find opportunities. The Better tool has become a very useful tool in that regard. It cuts down a lot of our time. It makes us help target our efforts better. So I want to talk about some of those benefits that Carolyn started to allude to. So the portfolio portion of the Better tool is actually very powerful. It allows us to do benchmarking across similar building types. So one of the inputs to the tool for each building is what's the space type. Are you an office, a data center, courthouse, etc.? And by doing that, you're comparing like buildings in a group, in a portfolio. The tool, since it is normalizing by weather data, doesn't care if it's different square footages or geographical location by weather data. It normalizes it all together so that you can see an apples to apples comparison, which is very useful. It also helps with targeting efforts. So the figure on the left you can see here is an example of some buildings that we grouped together in a cohort, and the green bar showing the energy savings cost potential, and the pink and red, pink and blue showing the use energy, site use energy by fossil fuels and electric. By using this, you're able to kind of see the potential for each building. But it should be noted, things that we've learned while using this tool is while you can see in the center, that very tall green bar next to the very tall blue and red is the highest dollar saving potential, but it has to be relative to the building. On the far right-hand side, you can see that there's another building that has even a higher cost savings relative to the energy usage of the facility. So you have to play that game of what is the most bang for your buck, depending on what you're looking to do. And for the state agency we're working with, cost savings and implementation costs were prohibitive. So we were trying to find the best value for them. And that's one way we were able to do that. Additionally, we use the Better functionality of grouping like opportunities and like options. So if we are finding that there are similar cooling set point issues or economizer issues, it helps us start to point out if there is a systematic wide issue, or if there is a unique issue to each building, or if we need to dive into each one individually to find the problem. So we can benchmark using the Better tool the whole portfolio and see what the commonalities are between them. And it helps in identifying opportunities. It helps in seeing where we can save energy easiest, and figuring out which buildings are the ones, okay, we want to start retro commissioning, let's focus on the easy ones and search by those measure types. Next slide, please. So I'll talk about a little bit about how we use it for the state agency. There's a large number of buildings in California, as it is a big state. So step one was, well, we don't want to use 450 buildings and benchmark at one point. You can, the tool is capable of doing such things, but the value you'll get out of it won't be as significant if you're able to group into lower cohorts. So we looked at that and we kind of added some items. We looked at demand, we looked at energy usage intensity, and also some savings potential based on what the tool has found. By taking that, we were able to bring that to down 20 or 25 buildings, and we could have done a real depth analysis on it. So we could find what the opportunities were and help target better. The result was the energy savings across the portfolio were pretty significant. There are about 33 million kilowatt hours potential if they did all the opportunities, and 900,000 therms. So around $6.4 million in energy savings resulting for the cohorts we looked at. So it's sizable. There are some opportunities that can be had. We also looked at what are the common measures. The common measures included scheduled optimization, economizer repair, or economizer optimization as well, set point adjustments, and some lighting loads. So we were able to find this commonality across all of them thanks to the Better tool. Next slide, please. So I'll dive into one building in detail. We'll go over how we looked at it, how we used the tool, and how we got to where we were, and the results of our findings. So using the Better tool, we did a cohort and we found, oh, this is a great opportunity, has a great savings potential, and it's a large square footage, a high UI building. Well, let's look into it in more detail. So we ran the Better tool specifically for this building, and we found some opportunities, increasing cooling set points, decreasing heating set points, equipment schedule issues, and some economizer problems for the air handlers. So from there, we started going, okay, well, what else can we look at? I looked at the change point model of the electricity. I noticed that the change point model is kind of flat. As Carolyn went through in her slides for some change point models, we're looking for a flat line and then a ramp up, showing that they have a pretty good base load and it has a better part load efficiency as the load the building requires. But we notice this is more of a flat building. I also know this building is relatively new. It's about a 7 to 8-year-old building. So I would expect it to have a better change point model. So that was one anomaly. So with that, we ran our IDEA tool, which is a interval data energy analysis tool, and it generates this heat map. And this heat map gives us better insight to how the Better tool was functioning. So we noticed that there's a time around 21 hour, so that's around 9 p.m. at night. And we go, what's causing this pretty large increase? Because the darker in red, the more demand, the lower in green, the lower demand on the electricity bill. And at first, it's very intuitive. We go, oh, that's lighting. Janitors come in, they do lighting, they don't turn things off, but it's a lot more than that. It's a jump of around 50 kW up to 400 kW. So it's a sizable load. Something's turning on. After divulging more, I was able to see, oh, they have a ice storage or they have some kind of thermal storage system on site. So you can see that from this. So comparing the two together, I was able to figure out, oh, so they have a change point model that's kind of flat. They have an ice storage system that causes the problem. So these cooling and heating set points are probably resulting of that. Then the economizer problem was something to take a note at and see if that was a reason for the part load efficiency losses. And so we said, this is a good candidate. I'm interested to go on site. There might be some opportunity. And I did a site audit for this facility. And yes, they had an ice storage system that needed some tuning. It was not optimizing perfectly. It had some ways to save energy in the storage system. Some of their cooling and heating set points needed to be adjusted because they didn't install window filming in certain areas of the building, resulting in excess heat loads. So after doing that, they solved that problem. And then also the economizers on the south side of the building where they're located, some of them were stuck open or stuck closed, depending on what they were doing, due to a programming or a sensor location. So we were able to find all these, and instead of doing a 2-day audit, which I would dive into everything, I was there for 4 hours, and I was able to identify actually more than saved potential. I think I estimated around 15% saved potential that we're currently working with the building to try and achieve over the next year. So using this tool helped me set up my time so that I was using it more effectively. We reduced time inside the facility so that the engineers and operators could be more effective on how they operate the building. And we found some energy savings opportunities that were very cost effective, that the better tool helped me identify, and then we support it with our assessments and experience. So I think I'm going to hand it back to Carolyn now for kind of last comments regarding the better tool.
Thank you so much, Ethan and Eric, for that incredible presentation. I myself learned quite a bit when I hear about actual application of our lightweight web app and how it supports preparing buildings for upgrades. I just would like to take a moment and then once again acknowledge the U.S. Department of Energy, who has made Better possible. Again, Better is a free public access web application available at the lbl.gov website. Feel free to email us if you have trouble finding this tool. Also, to thank Johnson Controls, who developed Better under a cooperative research and development agreement with Berkeley Lab, and our colleagues at ICF International, who supported us in development of the tool. I just want to take a moment to indicate that we plan to release an upgraded version of Better in June. That'll have some additional data storage capabilities, along with some enhanced reporting functions, the ability to create and circulate self-contained HTML files with all of the single building and portfolio analytics that I showed during the live demo. We're quite excited about that. I think now we're ready to open up to questions from the audience. Thank you.
Great. Thank you, Ethan, Eric, and Carolyn. Let's head into questions from the audience. And for those of you who haven't submitted a question yet, or you have one lingering, submit it to that Q&A button you see on your screen, and we'll make sure to get to it. So Carolyn, the first question I have for you, one attendee is asking, one of the slides noted that the building data for the Better utility program can be imported from the Energy Star portfolio manager. And they're asking, can data be exported from Better to be used in Portfolio Manager?
Oh, that's a fantastic question. Oh, great. Yes, so we can import data from Portfolio Manager. At this time, we don't have an export capability to Portfolio Manager, but we are working on a capability to export data to the standard energy efficiency data platform of the U.S. Department of Energy, which is a platform to help organize and sort of organize and manage building energy data. From there, there is possibly connectivity to Energy Star, but I'm going to take that down as an important recommendation from industry, and I think we'll look into whether we can create an option to export Better files over to Portfolio Manager. It's a great comment.
Cool. Next question. It seems that weekly and daily occupancy would be a key factor in building modeling. Does Better include that?
Great question. Better doesn't normalize for changes in occupancy. The tool was designed to use as few data points as possible to be able to target energy efficiency opportunities in buildings and portfolios remotely. So while we know that occupancy and operating hours do impact energy consumption and are used in other benchmarking tools such as the Energy Star Portfolio Manager, we deliberately excluded them from Better because we want this tool to be as simple as possible to use with a few data inputs, but still be able to create these valuable change point models and perform benchmarking analysis.
Thanks, Carolyn. And someone just posted in the comments, I believe this was a follow-up to the first question. They're asking, can you please show some examples of building data files, or what information in what
Sure.
format would be
Yeah.
acceptable?
Absolutely. Apologies, I didn't share that earlier. I'm going to just get out of the presentation and I'll share the files. Okay. So as mentioned before, Better currently offers two options for data entry. The first is an Excel data template. You can see I just clicked on the link. It downloads to my computer and pull it over to my desktop, and I'll open this file. And bear with me, it's a little bit slow, my computer. Okay, so the data entry template is a simple Excel template. We provide instructions, including what data needs to be input and where on the spreadsheet template to input it. So this is just instructional on the first tab. The second tab includes property information. So in this case, we've entered dummy data for a portfolio to support users. They'll need to indicate an identification number for each individual building in the portfolio, provide a building name, a location, a gross floor area, and the type. The space types are those also identified or utilized in the Energy Star Portfolio Manager system. So in the case of perhaps the ERI portfolio, they perhaps were working with courthouses. So they would select that space type. Here at the top, a user can indicate whether they want to work in standard international units or imperial units, and Better will provide outputs according to the unit system selected. Currency is also an input here. We've developed the tool to be useful internationally, so we offer quantification of size, quantification of cost savings in different currencies. This next tab here is the utility data. So for each building entered by a user on the property information tab, they'll want to transfer that unique building ID over to the utility tab, and they'll indicate for this particular building the billing start date, end date, and the energy type they want to enter. Again, we mirror the energy types that are input into the Energy Star Portfolio Manager tool. Most often, users are entering electric consumption from the grid. They'll select the appropriate unit. We offer a variety of options, and then the consumption level here and the cost level if they have it. If they don't have cost, we'll calculate an estimated monthly utility cost based on proxy utility bill information according to the location of the building. So in the case of building 1, they would enter 12 consecutive months of electric consumption. If there are any other fuels used at the building site, they would also enter 12 consecutive months for those fuels. In this case, natural gas. And they've entered in therms and they indicate the consumption amount. So that's for building 1. They would do the same for building 2, 3, 4, and so on. Glossary of terms here just gives a little bit more detailed information of how we define various building types for users. So this is one data entry option. We also have the Energy Star Portfolio Manager template and some quick instructions how to go to Portfolio Manager, log into your account, create a custom download where you can select the buildings from your Portfolio Manager account that you want to analyze using Better. We indicate what radio dials you need to check off to run the report. Portfolio Manager will auto-generate an Excel report in literally seconds. It's so amazing. And we have a sample Energy Star template here pre-populated. Again, this was just a handful of buildings in California. This is a auto-generated report from Energy Star Portfolio Manager, so no work on a user's part. And all they'll need to do once they've generated either the Portfolio Manager report or the Excel report is select the data entry template they're going to analyze, click Browse, and upload it from their computer. This is Energy Star. Upload it, and then Better will start the calculation. We'll select the type we want to analyze, and then we'll see the buildings here. We select the buildings we want to analyze and click next. And then we're off selecting the targets, the statistics, and R squared levels. So I hope that's helpful clarification.
Thank you so much. We do have a few more questions lined up here. I think this next one was for what came in when Ethan was presenting. What is the source of the EUI data?
Great. So what Carolyn just went over, entering the information on the utility data on the through Energy Star or manual through Excel, that's the source of the EUI data. So it takes that, normalizes it by the weather data, and applies it to the building square footage.
Perfect. Thank you so much. And this next question, maybe a combo with Ethan and Eric. There's just two questions. Someone's asking, can you explain how the owners save from utilizing the RCX? And then also, can you explain how the payback was less than 1 year for RCX?
Sure. So the retro commissioning activities, they vary on breadth and cost. So retro commissioning are the no cost, easy controls upgrades you can do for facilities to improve part load efficiency of buildings. Great example of which is a supplier temperature reset measure. So resetting your supplier temperature from your air handlers to the building based on either load or outside conditions. Some buildings do it, or they don't do it well, or they're not using it for some reason. So take some programming, go in, implement it, and they usually have very high cost savings relative to the implementation costs. And that's just the nature of the controls measures that we find. So the tool is really good at finding those opportunities, which typically result anywhere between 4 to 12 months in regards to simple payback for majority of these opportunities. There are some that fall outside of that, but that's primarily where they fall. Eric, anything else you want to add to that?
I think that's a great explanation. Yeah, I think that you nailed it. I think, just a range of some other opportunities that we mentioned, scheduling optimization, other types of resets, duct static pressure reset, or, economizer optimization. All these are different types of strategies that are used for retro commissioning, and like Ethan mentioned, have oftentimes have paybacks in a matter of months. So yeah, that's an overview of what that involves.
Great, thank you. Next question, we have two questions on the Stockton office building. So I'll start with this one. What was the total cost of the energy analysis for the Stockton building? And how many years were expected for the payback, since the potential cost savings was $74,000?
Great question. So the Stockton building, the cost of the energy analysis is kind of varies by building to building, depending on level. The use of the Better tool allowed us to do a pro bono cost assessment for them to get involved with the project. So this took, I think, maybe 50 minutes of my time to run the model, run our RDO tool, and then compare them and find and see, yep, this is a great opportunity. So it doesn't take a significant amount of time if you have the right resources and engineers taking a look at it. In regards to the expected payback, for this building, there was some capital required projects to go along with it due to some general system upgrades, and I think some VFDs on some equipment. So I believe the payback was 1.2 years for this project, and we're currently working on the implementation. So we'll hopefully get a result in the coming few months to see some savings verified.
Thanks, Ethan. And then follow-up question to the Stockton building. The cooling energy use and cost was identified as higher than the benchmark based on the blue bar. Thermal storage in place. Is this higher cost expected and explainable?
Higher cost. The thermal storage and the higher cost expected and explainable. I'm unsure what they mean by higher cost expected.
Okay. Well, we can move on to the next question. If they have an explainer, maybe they can follow up with me.
That'd be great.
Perfect. All right. Next question for you and Eric. have either of you used this tool for data centers or know anyone that's used it for data centers so far? And if so, can you expand upon it or have any information to share on using it?
Eric, you want to take that one?
I believe we've used it for a quick comparison on a couple of data centers that we've looked at, and I can say it hasn't been our primary focus, although we do work with data centers regularly. So, but I believe the tool has been fairly effective in that. I think the ones that we've looked at are buildings that have a data center, kind of a medium-sized data center within them. And so from that perspective, yeah, it gives a good representation and able to deliver measures that make sense for that facility. Yeah, I'd say the primary focus for us has been using it on like general office type buildings for the most part to this point. So, but that's a good question. I think, you know, as we use it more for those building types, we'll be able to speak to that a little more. Yeah.
Okay, thanks, Eric. Next question on utility data. Can the electric demand charge be entered into the system? And if so, can the program define any EE from the demand charge comparison to a benchmark?
I don't believe demand is current. Oh, go ahead, Carolyn.
Yeah, I was going to say exactly the same thing, Ethan. We don't currently ask for data on demand charges, but it is something we're exploring, how better could be enhanced to support targeting of demand flexibility opportunities. One thing we're considering is collecting data to allow us to calculate the monthly load factor, and thereby determine again whether certain buildings would be good candidates for demand flexibility measures. That's a work in progress, but at this point, no, we're not taking the demand charge. We may in the future though.
Thank you. And next question, what's the software development platform that's being used to generate the source code and APIs?
We're using Python. So if you go to the Better web app and you go to the source code page, it'll take you right to GitHub and you'll see the code in the code in Python.
Perfect, thank you. And I think we have time for just one more question here. In college or hospital campus buildings where individual building utilities are not always being metered separately or sub-metered, is better HV capabilities or APIs able to split the utilities from centrally metered system?
Sam, can you say that one more time? There was a point there that I missed. So they're looking at large hospital campuses?
Yes, in a college or hospital campus building where individual building utilities, I can keep going, are not always being metered separately or sub-metered, is better HV capabilities or APIs able to split the utilities from centrally metered systems?
Yeah, that's a great question. So at this point, Better doesn't have the intelligence within its software to split a centrally metered campus by building. It's something we would be curious to learn more about, the challenges that are being faced. At this point, the Better web app takes data from building level or whole building meters and analyzes, again, the monthly consumption and cost for for an entire building that's individually metered. We are looking into being able to handle interval data, sort of rolling that up to the monthly level to create the plots, the inverse plots. And then in terms of centrally metered campuses, we've got to think about some way to address that, but we haven't done that yet. It's a great comment.
Wonderful. Carolyn, do you mind fast forwarding to the final slide there? Just want to close things out. Carolyn, Eric, Ethan, thank you so much for your time today and stopping by and letting us know a little bit more about the Better tool. For those of you here with us today, CxEnergy is almost over, but not yet. We still have one more session that is on Thursday, this same time. We'll see you there. It's on understanding emergency power system commissioning, and we hope to see you there. Thank you so much.
Thank you, Sam.
Thanks all.
Thanks, Sam. Thank you all.
Thank you, everyone.